Next, we're going to look at what happens if we're trying to do a power to another power. So we're going to look at problems that are raising powers to powers. So first, let me give you the general rule, and then we'll do a couple examples. So our general power rule, power to a power, says that if you have x to a power and then raised to another power, you multiply your exponents. So you will end up getting x to the 8th because you're going to multiply your 2 and your 4. So power to a power, we multiply. Now, if we have a number to a power, so like this one that we're looking at here, we are just going to take 5 to the 4th power. We don't have to worry about exponent rules here because 5 doesn't have an exponent. It's truly just to the first power. So we're going to do on our calculator 5 to the 4th power. You're going to hit 5 and your caret button 4 to get your coefficient. And then from there, you're going to do power times power, power times power. So x is to the first power and then to the 4th power. So 1 times 4 is 4. And then y is to the 4th and then to the 4th again. 4 times 4 is 16. So you're going to multiply your powers of your exponents. But the numeric piece, that's when it really helps to have a calculator. Grab your calculator, take 5 to the 4th power. I'm going to show you one more of these. So this one, I'm going to take 4 to the 2nd power. Probably don't need a calculator for that. 4 squared is 16. And then you're going to multiply the exponents together that are with your variables. So 5 times 2 gives you x to the 10th, and y 1 times 2 gives you y to the 2nd. So let's go back and now look at dividing. Put both of these in the same video. So if we talk about dividing powers, so when we are dividing, our rule for division, if I have x to the 7th over x to the 3rd. So if I have the same base and we are dividing, you are going to subtract your exponents. And the reason is because you have 7 x's on the top and you have 3 x's on the bottom. So you are left with 4 more x's on the top. And that's a great way to think about it. You can even write it out and say, well, I've got 7 x's on the top. 1, 2, 3, 4, 5, 6, 7, and I've got 3 x's on the bottom. And so what ends up happening is all of this x would cancel this one cancels with this one cancels with this one, and I'm left with 4 of them. So that's why you subtract, if you ever wondered why the rule happens. Now, if you have numeric pieces, if you have coefficients, you want to see if that will reduce just by using basic fraction simplifying. So 2/8 reduced to 1/4. You do not have to use an exponent rule because, again, there are no exponents there. So then I'm going to go with my x's and my y's. Now, something to notice here, I actually have more x's on the bottom and I have more y's on the bottom. So when I subtract, and we're going to talk a little bit about this in other videos, I'm actually going to end up with my resulting x's on the bottom. So I have 3 more x's on the bottom than I do on the top. Same thing with the y's. I have 5 more on the bottom than I do on the top. A great rule of thumb is to say that your final answer is going to have that variable wherever there were more to begin with. So there were more x's to begin with in the bottom, and there were more y's to begin with in the bottom. Let me show you another one. So with this one, you're going to do your 12 divided by 6. That divides to just 2. When you work with your x's, you have 3 more x's on the top than you do in the bottom, so you get x to the 3rd. And what you'll notice about your y's is they cancel completely. So when you have the exact same exponent on the top and bottom with that same base, they will cancel and they will not be part of your answer. So that is going through division.